Hello everyone, I am Dr. Millie Kulshrestha and today we will discuss Lewis acid and Lewis base. We have gone through Arrhenius concept of acid and base. We have seen Bronsted and Lowry concept of acid and base. Now, some of the things are left, some of the compounds were left which were not explained in the as an acid, which their behavior were not explained as an acid, as a base. These compounds like AlCl3, like BF3, like NH3, these compounds, the behavior of these compounds as acid and as a base can be explained by the concept Lewis acid, Lewis bases. So let us talk about these acids and base. Here in this particular Lewis acids and base, we have to understand only one concept, that is acceptance of electron pair and donation of electron pair. So the main thing here is we will talk in terms of only electron pair acceptors and electron pair donors. So the species which have tendency to accept electron pairs are called Lewis acid, and the species which have tendency to donate electron pairs are called Lewis bases. Now one thing here is that why some of the species accept the electron pair and why some of the species donate electron pair. So let us try to understand why some of the species accept and why some of the species donate. So I am talking about here why some of the species accept electrons. Accept electrons. Let us take an example of BF3. It is a Lewis acid. Why I am calling this Lewis acid? Let's understand its structure. What is boron? It is B5. And what is the configuration of boron? 2, 3. How many electrons are there? 3. So if boron connect with, if I draw the Lewis structure, Lewis dot structure, boron will be this, and it is connected with the fluorine, like 1, 2, 3, 4, 5, 6 and 7th electron of the fluorine. Same way, fluorine 1, 2, 3, 4, 5, 6 and 7th electron of the fluorine. And there is the last fluorine here, 1, 2, 3, 4, 5, 6 and 7th electron of fluorine. So you can see there the fluorine is satisfied with the 8 electron in the outermost shell. If we look at the boron outermost shell, can you see there is only 6 electron in the boron outermost shell? If there are 6 electron only, how it is possible for the boron to exist for the longer time? So this will have a tendency to accept lone pair of electron because of the presence of empty orbitals. So these empty orbitals which are not having lone pair of electron, these empty orbitals are responsible for their attraction towards the lone pair. So this is why these type of species which are having less number of electron in the outermost shell, that is their octet is not completed, in a electron deficient species, we call them as electron deficient species. So these electron deficient species behave like a Lewis acid because they have tendency to accept the electron. Okay? On the other hand side, if any species is having positive ion like H plus, if it is Ag plus, if it is Cu plus 2, these species because of positive charges they also require electron. That is why they have some attraction towards the electron and they show the tendency to accept the electron pair. Let me show you the example of H plus ion. How H plus ion accept the lone pair. Let me give you one example. When we dissolve this HCl in water, what happens? What we used to do is H plus ion is released and Cl minus is like they break down, and in the presence of water only this happens, that water has tendency to take the H plus ion towards itself. Na? So क्या होगा? Why it is happening actually? Why? How it is possible for the water to attract this H plus ion? The reason behind the H plus ion. What is H plus ion? Hydrogen is having only 1 electron and the configuration is 1. You have seen you are seeing there that there is one positive charge. It means what? It means we have released this 1 electron. अभी इसके पास नहीं है, means there is nothing with the hydrogen. It is having no electron. तो क्या है इसमें? There is only positive charge in the center of the nucleus. ठीक है? That's at the center of this hydrogen atom. Now what is going on? Look at this water. This water is here having 2 lone pair of electron on the oxygen and these two lone pair of electron are available with the oxygen, तो ये क्या करेगा? This is going to support this H plus ion. So this can support because it has extra lone pair. So these kind of species like oxygen having lone pair, so this can donate this lone pair to the hydrogen. Hence here this H plus ion, because it is accepting the electron pair, it is an acid, and because it is donating, so it is behaving like a base. So this is lone pair donor here, and this is lone pair acceptor. And when it will accept like H, O and its lone pair between the hydrogen and oxygen, and this bond which is there in between, but it is shared by both of them, but the electrons belongs to only oxygen. This is called coordinate bond. We have done it in the chemical bonding, so this will be shown by this only. And the positive charge, now it is happy, hydrogen is happy, but the electron which were belonging especially to this oxygen are now being shared with the hydrogen, तो इस पे आ गया positive charge. Hence this species turn into H3O plus. तो we used to write it down like this, not like this. हम इस तो समझाने के लिए मैंने बताया है. तो this is what H3O plus is formed this way. So this is called coordinate bond. But here we are talking about what is Lewis acid, what is Lewis base. So you can see there it is accepting electron, Lewis acid. It is donating electron, so it is a Lewis base. Okay? So this is how it is working. So what are the two reasons? The first reason is that the species is not having any it is having a vacant orbital. Then it has the tendency to accept the electron. Otherwise, the possibility is that a species is having positive charge, and this positive charge means lacking of electron. Hence, it is attracting the shared pair of electron. Same way, जैसे copper का ले लेते हैं. तो if I am talking about the copper, so look at this example. This Cu plus 2 is there. So obviously, there is plus charge. It will have some attraction towards the lone pair of electron. तो क्या होगा? There is a formation of NH3 plus 4. CuNH3 plus 4 positive. This is formed. This compound is formed with the ammonia. Why with the ammonia? क्योंकि ammonia is NH3 and this NH3 is having 2 electron. That is lone pair of electron which is not involved in the bonding, and this electron is available for this copper in its empty orbital. It is going to occupy. ठीक है? So this is why it is working as a, this is the acid here because it is accepting the lone pair from the ammonia, and this is base here because it is giving the electron to the copper ions. So I hope it is clear that there are two possibilities for a substance to behave like an acid. The first is कि उसका orbital खाली हो. The empty orbitals may be responsible. If they have empty orbital, their outer shell is not completed, their vacant shell, like valence shell is not completed, then they can accept the electron pair. On the other hand side, if they have positive charge, so they will get attracted towards the negative lone pair of electron. In that case also they will behave like a acid. Let us talk about the bases now. And what are Lewis bases? Lewis bases are electron pair donors. Electron pair donors will definitely have some electron pairs which will be free to get donated. Free to get donated means they will be not involved in the bonding. So electron pair may we will be talking about the lone pair of electron. Lone pair of electron which is not involved in any kind of bonding. Let's take the example of ammonia. So here we have ammonia. What is nitrogen? Nitrogen is 7. What is the configuration? 2 and 5. If it is 2 and 5, Lewis dot structure of nitrogen will be this. How it will make ammonia? By connecting with hydrogen, hydrogen and hydrogen. So you can see there this is a satisfied compound where the hydrogen is satisfied with the 2 electron. अब ये जो बचा, this is not involved in any kind of bonding, and just because it is not involved in bonding, this can be utilized to donate electron wherever it is needed. If someone comes who need the electron, this electron pair can be donated to them. For an example, if H plus ion is there around, what it will do? This H plus ion will come near to it, or I can say that this lone pair will be donated to this H plus ion, and these two will bond with each other. How? Now nitrogen, hydrogen, 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 and this lone pair will be between hydrogen and nitrogen. But these two electrons belong to this nitrogen, but this hydrogen is sharing with them, these electrons. तो क्या होगा, हाइड्रोजन पर it is satisfied because it is having now two electron which is being shared, but this nitrogen will acquire positive charge. So this is how NH4 ammonium ion is formed, and in this ammonium ion positive charge appears on the nitrogen. So what is losing the electron, what is donating the electron? A nitrogen. In this particular compound, nitrogen is donating the electron, but as a compound, this compound will be named as Lewis base because ammonia donates its electron to the hydrogen plus ion. A hydrogen ion is accepting the electron, so this is working as a Lewis acid, and this ammonia which is donating the electron is going to work as a Lewis base. Is it clear? Same way as I have already discussed, we have water, and water is what? H2O having two lone pair, and these two lone pair can be donated to others. So this water is also a Lewis base. On sometimes whenever it is needed and whenever the situations will be of that kind ki water has to donate, then it will be definitely donating electron. So I hope it is clear that if some species are having lone pair of electron on them which are available for the donation, which can be donated, means they are not involved in the bonding, then that species can work as a Lewis base. On the other hand side, some other kind of species which are having electron on them, they can also behave like a base because they can also donate their electron pair. For an example, if we talk about AlCl3 and we react this AlCl3 with Cl minus, and you can see there this Cl minus means what, how many electrons are there in the outermost shell of chlorine? There are 7 electron, and one is accepted by it क्योंकि इस पे minus charge है, it means it is already accepted 1 electron. There are 8 electrons. Now it is having 1 charge on the chlorine. Now look at this AlCl3. AlCl3 outermost shell में there are 3 electrons. Okay, it is connected with the chlorine, so Cl and Cl having 1 electron shared. Cl is satisfied because it had 7 electron and it has shared 1, so 7 plus 1 8 हो गया. This Cl will also be satisfied क्योंकि इसके पास भी 8 है, and this Cl will also be satisfied because it is also having 8 electron. Now you can see that this aluminium is not satisfied, तो ये हो गया आपका Lewis acid, and this is ready to donate its 2 electron क्योंकि इसके पास extra है because it is negative. So this electron pair, this is looking for someone जो कि electron जिसको चाहिए हो. So now these two will connect with each other to form the species called AlCl4. So this is how this chlorine minus ion can donate its lone pair of electron. This is donating, this is accepting. So this is what Lewis acids and Lewis bases are. Same way we have one more reaction जो कि आपके एग्जाम्स में आ जाते हैं sometimes, that BF3 react with NH3. In this case we have gone through, ये हमारा क्या है, Lewis acid because it has 3 electron in its outermost shell only, and this is what, Lewis base. And when these two combine, this will donate lone pair of electron to this P boron, and this will form, look at this, nitrogen H3 lone pair donated towards BF3. तो ये जो है, this is going to be formed this way. These two species, base and acid, will exist together to form a salt-like structure. So this is how they are satisfying each other. Now let me take one question from NCERT so that you can better understand it. And the question is, identify Lewis acid and Lewis base. Okay, so I am giving you example here, that is this. We have to identify whether this is a Lewis acid or it is a Lewis base. So first thing is that it is negatively charged. Negative charge will definitely will be donating lone pair of electron. बट उसके लिए ऑब्वियसली इट हैज एक्वायर्ड नेगेटिव चार्ज, तो ये लोन पेयर एक्सेप्ट तो नहीं करेगा बिकॉज इट इज ऑलरेडी नेगेटिव इन नेचर. On the other hand side, I can show you here that it is satisfied and it is having one lone pair extra which is not involved at all in any bonding, so that it can get the lone pair. So do remember, the one who is itself satisfied is going to do the charity. Same way, अगर आपका compound या आपका कोई भी species, not a compound, in this case it is ion ना, तो कोई भी species when it is itself satisfied but still it is having that something extra which it want to disperse, then only it will behave like a Lewis acid or Lewis base. So I am going to show you here. जैसे कि this oxygen is 8 and the configuration will be 2 6. 6 will be outermost shell electron. Okay, so there will be 1 2 3 4 5 6 electron in the outermost shell. Now you can see there is one minus charge on the oxygen. अब just because there is one minus charge on the oxygen, I am showing it here कि इसने एक इलेक्ट्रॉन एक्स्ट्रा ले लिया, means there are 7 electron in the outermost shell. ठीक है. अब हाइड्रोजन, वी आर कनेक्टिंग वन हाइड्रोजन. हाइड्रोजन का स्ट्रक्चर में देयर इज वन इलेक्ट्रॉन, तो दिस हाइड्रोजन इज सेटिस्फाइड. ओके, दिस ऑक्सीजन इज सेटिस्फाइड. But the main thing here is this OH is getting satisfied but after getting one electron, and that one electron is a trouble for them. So it want to disperse the charges using some trick, and that trick is to donate the lone pair of electron. तो जब ये अपना कोई lone pair of electron donate कर देगा तो that sharing will make it satisfied. कोई प्लस आ जाए और इसका माइनस चला जाएगा, so that both of them together will be happy. For an example, अगर यहाँ पे मैं H प्लस ले लेती हूँ, okay, this H plus is looking for the electron, this OH minus is having extra electron. अब this extra electron में lone pair electron का डोनर होना चाहिए. This H plus is looking for what? इसका outermost shell कब complete होगा? When it will have 2 electron in its outermost shell. पर इसमें तो एक भी नहीं है, तो it needs lone pair. कौन देने वाला है? This is going to help it out. कैसे? इस हाइड्रोजन प्लस आयन को I am going to keep here, and this is going to share its इलेक्ट्रॉन. किसका? जो ऑक्सीजन का है. नाउ दिस इज शेयर्ड बट दिस शेयरिंग इज ओनली फ्रॉम द ऑक्सीजन साइड. दिस टाइप ऑफ शेयरिंग इज कॉल्ड कोऑर्डिनेट बॉन्डिंग. तो अब क्या हुआ, एक H प्लस के साथ ये बॉन्ड बना. अब नाउ बिकॉज दिस वाज प्लस कमिंग टू इट, तो एक प्लस और एक माइनस मिलके देयर विल बी नो चार्ज ऑन इट. So this water molecule is formed this way. You can say that. So you can write it like HOH. And how many lone pair are left out still? This is one lone pair and this is another lone pair. And just because these lone pairs they are repelling each other, the bond will be shifted this way. And ultimately the bond will be like OH. And these lone pair are still ready. कोई आता है तो they will help them out. एक और H plus आ जाए, ठीक है, हम H3O बना देंगे, isn't it? So this is why this OH is going to work as a Lewis base, because this OH because this OH is donating lone pair of electron, and lone pair of electron donors are called Lewis bases. एक और एग्जाम्पल देखते हैं. In another example we have F minus ion. So let's take the example of F minus and try to find out कि वो कैसे काम करेगा as a Lewis base या फिर as a Lewis acid. F minus ion. What does it mean? It means fluorine is what? Fluorine is 9. What is the configuration? 2 7. 7 means there are 7 electrons in the outermost shell. So 1 2 3 4 5 6 7. If it gains one electron, that is why the charge is appearing ना. तो this is done. ये हो गया पूरा satisfied तो है, but how it is satisfied? By with the minus charge. तो ultimately it want to disperse its minus charge. तो again I can go for the HF बना सकते हैं लोग. So what is there? H plus ion. So what this H plus without any electron अकेला आया है, तो this will be sharing its electron. तो इस पे जब ये इधर चार्ज देगा तो इस पे कौन सा चार्ज आएगा? वैसे ये पॉजिटिव चार्ज इसका तो गया, और ये पॉजिटिव और ये नेगेटिव मिलके हो गया माइनस. या मैं ऐसे बोल सकती हूँ कि इसका प्लस कनेक्टेड विद दिस, इसका माइनस विल बी सेटिस्फाइड विद इट्स पॉजिटिव चार्ज. तो इसकी कमी और इसका एक्स्ट्रा एक दूसरे को सेटिस्फाई कर रहा है, ठीक है. सो दिस इज व्हाट वी आर हैविंग HF. This single bond here is indicating what? This is indicating single bond is indicating coordinate bond, and that coordinate bond means the sharing from the one side only, never formed from the both the side. General sharing covalent bonding in the covalent bonding. General sharing is having one electron from both the side in a single bond, but here this single bond is made up by the coordinate bond, by the one-sided loan, like one-sided donation. In the coordinate bond, we don't show who is giving the electron. This is kept in between only, and one-sided sharing it is, but there is no difference in showing in the representation. So this is what Lewis acid and Lewis base concept is. So I hope this video will make it clear to you that what are Lewis acid, what are Lewis bases, and how you are going to recognize them. The main thing here is Lewis acid इलेक्ट्रॉन पेयर एक्सेप्टर हैं, and the electron pair which can be donated are those electrons which are not involved in the bonding. तो अगर आपको कहीं किसी भी स्पीशीज में इलेक्ट्रॉन पेयर्स मिलते हैं विच आर लोन पेयर टाइप ऑफ, हमें पता है कि स्ट्रक्चर्स में देयर आर टू टाइप ऑफ लोन पेयर्स, बॉन्ड पेयर, लोन पेयर. बॉन्ड पेयर आर दोज विच आर इन्वॉल्व इन द bonding, lone pair are those which are not involved in the bonding. So you do remember कि only those electron pair can be given to others, can be donated, which are free, which are not bonded या which are not involved in any kind of bonding. ठीक है? So I hope this video will be helpful for you to understand the concept. If you like this video, please hit the like button, share it and subscribe my channel. Thank you very much.